Hello guys, let's have a look at another question here. Let's start reading the question. Figure 9.1 shows a beam of alpha particles moving towards a thin sheet of gold in a vacuum. Detectors in the region surrounding the thin gold sheet detect the alpha particles and determine the number of particles that travel in various directions. So just a heads up before we go ahead and read the rest of the questions. We understand that the beam of alpha particles could going straight, could be deflecting at an angle, could be deflecting at a much larger angle than intended, and could also retrace their path. All of these scenarios are perfectly plausible. Although they are not possible in the same probability, all of these are still possible. Let's start with part 1. The majority of the alpha particles pass through the gold sheet undeflected, and they are detected on the far side. So with this statement, we are supposed to state and explain what can be deduced. The deduction is that there is very little or in fact no obstruction offered as these alpha particles pass through the thin gold foil. A quick heads up, alpha particles are particles which are made up of 2 protons and 2 neutrons. While the neutrons are neutral, protons are positive, yielding an overall positive charge to these alpha particles. The explanation for this very little or no obstruction offered is because most of the space inside an atom, most of the space inside an atom is empty. Moving ahead, a small number of alpha particles are deflected as they pass through the gold sheet. So we also understand that a small number of alpha particles are deflected as they pass through the gold sheet, which is again detected by the detectors as shown. The deduction is that there must be a positive charged center inside the atom, which we will term as the nucleus. So why did I assume the nucleus to be positively charged? The simplest reason is the fact that the alpha particles are deflected just tells us that the alpha particles were repelled. And from the law of attraction and repulsion of charges, we understand that like charges repel. And since like charges repel, the alpha particles are only deflected if they were repelled. And this repulsion is because of the positively charged, concentrated, in fact, densely concentrated center of an atom called the nucleus. Moving on to part 3, a very small number of alpha particles are deflected through very large angles, or in fact, even return back to where they came. So here they're referring to these particular scenarios. The scenario where they're deflected by a large angle, or in fact, even retrace their path. So this fact tells us that the nucleus is not only positive, the nucleus has a high magnitude of positive charge and that it is densely concentrated. The fact or the reason that I assume the nucleus has a very high magnitude of positive charge or that it is densely concentrated is because the alpha particles were not only forced to deflect at an angle, they were also in fact forced to retrace their path. This can only be possible if there is a very high positive charge which applies an electrostatic repulsive force such that an electrostatic repulsive force such that the alpha particles are in fact even forced to retrace their path, which requires a very high amount of potential energy. Moving on to part B of the question. A beam that consists of both alpha and beta particles is passed through a region of space where there is a magnetic field perpendicular to the direction of the beam. So a beam of alpha, here alpha are positive, beta is nothing but electron being released, so negative, or pass through a region of space where there is a magnetic field perpendicular to the direction of the beam. We know that charged particles do experience, in fact, a deflection when placed in a perpendicular magnetic field. So to conclude, there is going to be deflection. Let's read the question. State two ways in which the deflection of the alpha particles here differs from that of the beta particles. So while both alpha and beta particles do deflect, we understand that alpha particles are going to be deflected in the opposite direction to that of beta particles, simply owing to the fact that they both have the opposite polarity of the charges between them. Second one, we also understand that since alpha particles, in fact, the composition of alpha particles is 2 protons and 2 neutrons, while that of a beta particles is just 1 electron. And we know that a proton is about 5,000 times much heavier than an electron, while just having twice the equivalent magnitude of charge. Thus, since the charge to mass ratio of an electron is much more than that of an alpha particle undergo smaller deflections than beta particles, owing to the fact that their charge to mass ratio is much lesser than that of a beta particle. So these are the answers to our given questions. Thank you.